Dear students, in this video, we will learn how to prepare a standard solution of N by 20 Mohr salt and using this solution how to determine the normality and strength of the given potassium permanganate solution. The theory about the experiment is that the reaction between Mohr salt and potassium permanganate is a redox reaction. In this reaction, potassium permanganate acts as an oxidizing agent and Mohr salt, which is a double salt having the formula ferrous sulfate, ammonium sulfate, 6 moles of water, acts as a reducing agent. So this titration is an oxidation-reduction titration. The ionic reaction in the process is given as the sum of oxidation half reaction where ferrous ions are converted into ferric ions with the loss of one electron, and the reduction half reaction is written as potassium permanganate ion after gaining 5 electrons in the presence of acidic medium is converted into manganese 2 positive ions. The overall ionic reaction is the sum of oxidation half reaction and reduction half reaction and is given as MnO4 negative plus 8H positive ions plus 5 moles of Fe2 positive ions getting converted into manganese 2 positive and 5 moles of Fe3 positive ions are formed and 4 moles of water molecules are eliminated. Note that this titration is carried out in acidic medium by using dilute sulfuric acid in order to prevent precipitation of manganese oxide. The materials required for the titration are Mohr salt, potassium permanganate solution, dilute sulfuric acid, chemical balance, burette, burette stand, pipette, conical flask, funnel and measuring flask. The apparatus setup is KMnO4 solution is taken in the burette, Mohr salt and sulfuric acid are taken in the conical flask. In this titration, KMnO4 acts as a self-indicator and the endpoint of the titration is the appearance of permanent pink color. This is the schematic diagram of the experimental setup during the titration. Now the procedure. First of all, we will be preparing N by 20 standard solution of Mohr salt by weighing accurately 19.6 grams of it on a weighing scale. Dissolve the weighed Mohr salt in distilled water and transfer the contents into a measuring flask of 1 liter capacity with the help of a funnel. Make the solution up to the marked point with distilled water. Shake the solution to make sure that Mohr salt is fully dissolved. This solution is labeled as N by 20 solution of Mohr salt. Next is the titration of potassium permanganate solution against standard Mohr salt solution. First, wash and rinse the pipette with distilled water and then with Mohr salt solution. Rinse the burette with potassium permanganate solution and fill it with KMnO4 solution. Pipette out 10 ml of N by 20 standard solution of Mohr salt into the conical flask. Add 1 test tube full of dilute sulfuric acid to it to prevent oxidation of potassium permanganate to manganese dioxide. Note down the initial burette reading. Check the upper meniscus on the burette reading since KMnO4 is a colored liquid. Start titrating the Mohr salt solution by dropwise addition of potassium permanganate solution and shaking the solution in the flask gently. Keep adding potassium permanganate solution in the conical flask till a permanent pink color appears. This is the end point of the titration. Note down the final burette reading. The volume of KMnO4 used for the titration will be equal to the difference of final and initial burette readings. Repeat the experiment till 3 to 4 concordant readings are obtained. Calculations. Normality of KMnO4 solution is determined by applying the normality equation N1V1 is equal to N2V2. We know the normality of Mohr salt solution. 10 ml of Mohr salt solution were taken in the conical flask. Normality of KMnO4 solution is unknown, and the volume of KMnO4 solution can be obtained by subtracting the final burette reading from the initial burette reading. So in this manner, we will be able to determine the normality of KMnO4 solution. The strength of the solution is equal to normality multiplied by equivalent mass. Since 5 electrons are involved in the reaction, so the equivalent mass of KMnO4 is molecular mass divided by 5, which is equal to 31.6. And the strength will be equal to the normality multiplied by 31.6 and is expressed in the units of grams per liter. The precautions which need to be taken during the experiment are: clean all the apparatus first with distilled water, and before the experiment rinse with corresponding solutions. Always read the upper meniscus in the burette, as KMnO4 is a colored solution. Dilute sulfuric acid is used in the experiment in order to prevent the precipitation of potassium permanganate solution. Detect the endpoint when the solution gives permanent pink color, and don't keep adding the KMnO4 solution after it. Place white tile below the conical flask so that detection of endpoint is easier. Some of the Viva questions related to the practical are: what is a normal solution? A normal solution is the one that contains 1 gram equivalent mass of the solute dissolved per liter of the solution. Why is dilute sulfuric acid suitable for potassium permanganate titration? As KMnO4 acts as an oxidizing agent in acidic medium, if acid is not used, KMnO4 may be oxidized to manganese dioxide, giving a brown precipitate. Why is nitric acid or hydrochloric acid not used in this titration? Nitric acid is not used because it is an oxidizing agent in its own, and hydrochloric acid is usually avoided because it reacts with KMnO4 to produce chlorine, which is also an oxidizing agent in an aqueous solution. What type of salt is Mohr salt? Mohr salt is an inorganic compound with the formula ammonium sulfate, ferrous sulfate, 6 moles of water. So it is a double salt. Why is dilute sulfuric acid solution added while preparing a standard solution of ferrous ammonium sulfate? This is done to prevent ferrous sulfate hydrolysis. Dilute sulfuric acid solution is added in order to prevent hydrolysis of ferrous sulfate. Excessive heating is avoided when dissolving the salt mixture in water. This is for preventing the conversion of ferrous ions into ferric ions, which are yellow in color. Thank you so much for watching.